As we wrap up the laptop store project from the YByte Python curriculum available at www.ybyte.in, I thought this may be a good opportunity for us to take a step back and look at a little bit more general comparison between, say, dictionaries and lists. As we saw in the laptop store, dictionaries store data in what is called the key value pairs. Lists, on the other hand, we are very familiar with them. They store data, basically lots of data connected to each other in sort of, you can say, items with indices. So every item has an index, and that's how the data is stored. Now, we know that in a dictionary, keys cannot be repeated. Keys must be unique. Although they can have mixed data types. So we can have, for example, keys as being, say, strings. In the same dictionary, for example, integer could be a key or a tuple could be a key. However, we know that lists cannot be keys. Just like this, in lists, we can have different items that are of different data types. Even though the keys cannot be repeated, the values could very well be repeated, and same applies for lists. Items can be repeated. They need not be unique. In fact, we have seen all of this, in many contexts, to a large extent when we program. And, it looks like we can think of dictionaries basically as, from a functional point of view, let's say as lists with those, indices being replaced by the keys. And that's kind of what we start seeing, let's say, even in the laptop store project. From purely just say writing simple programs point of view, this may look okay. This is a reasonable viewpoint. But it's important to understand this a little bit more deeply, a little bit more clearly. So for that purpose, we'll take some, let's say, general examples and try to illustrate the difference between dictionaries and this, the most important differences. Now, let's just start with this mental experiment that let's say we have a list of numbers which are in no specific order. Let's say, there's a huge list of numbers. And I have to find, let's say, a particular number in this list. Just for illustration's sake, let's say these numbers are 91, 82, 81, 53, 56. And let's say, I have to find, for example, 72 in this list, just for the sake of illustration. Now, clearly, the way we would go about it is that we look at, let's say, item 1, I'll say actually item 0, item 1, item 2, item 3, and keep on going until we find the number, say, 72. We can imagine that as this list gets larger, this operation may take longer and longer. Now, why do I say may take, not will take? Well, because if we are lucky, maybe the very first element is the one that we are looking for. So let's say we were looking for 91. In this case, we are lucky. But you can imagine that as this list gets longer and longer, searching for a specific number becomes, in general, tough, because in the worst case scenario, we may have to look at the entire list one by one, which is a time-taking operation. Now, you might wonder what happens if this list is sorted. For example, let's say the numbers somehow have been arranged in a ascending order. Now, certainly the situation improves. The reason is we can do binary search because, basically we don't have to, we know that, look, that the list is, let's say, a million elements. I can search between, let's say, the first 500,000 and I can eliminate the half the list immediately. So that way we can zero down quite fast. If you remember in the number hunt project, we could take just 7 attempts and get to any number between 1 and 100. So, that's kind of where we are coming from, that if the list is sorted, the situation improves a little bit. Of course, effort and, computation goes in sorting the list. However, things change dramatically if, let's say, we had stored the same information in a dictionary. Just imagine that we have now a dictionary where we have stored the same data in key value pairs and we have assigned a key to every number. Now, just to make it more concrete, this data could, for example, be a student's score in an exam. Let's say, across a large population, we have lots of students. We store their names and their scores in a database. Now, the story changes completely because no matter how large the dictionary is, in fact, we can search for the keys in a fixed time. So that's a departure from the earlier situation. In case of a list, we had to sort of look through every item of the list. But in dictionary, for example, I can just go and say, okay, tell me the score, let's say for M. Basically, M is the key. Now, M is here not meant to be an alphabet, but this is some key, because remember, keys could be strings, keys could be tuples, keys could be, let's say, large integers, whatever they may be, right? some key. So I just say, okay, go tell me, find me the marks, let's say corresponding to M. I will get them in the same amount of time, no matter how large this dictionary becomes. And that's the fundamental difference, that basically dictionaries are very, very good for searching specific values, whereas typically lists are ordered. So if you want to sort, move data around, lists are more comfortable. Now at this point, I leave you with the food for thought. How will this situation change? Let's say if I did not use a dictionary, I used instead two lists. So one with a list of names of students and one with a list of numbers. Will this situation change? And if so, how? Happy to discuss. You can leave a comment. I'll be more than happy to discuss. So just sort of summarize this. Well, lists store information in a more compact fashion. They take lesser space in the memory. Lists are wonderful for operations like sorting and so on. With dictionaries, we need more space in the memory, but dictionaries are very, very, very quick for a lookup. Like I said, we just directly go to that specific key. This comes at a cost of a little bit more computation and higher storage. Dictionaries use something called hash functions, hashing internally to accomplish this. Now, that's kind of beyond the scope of this. However, I do want to highlight that, in order to be able to see these differences, feel them tangibly in, let's say, in a computing setup, we got to be dealing with, let's say, very large lists, maybe some millions of elements, and likewise large dictionaries, right? So this obviously, is important in many cases, but most likely you won't see them in, let's say, the simple programs that we are building. Good, however, to keep this in mind. Those interested, search on the internet, you'll find that it's discussed quite a bit. One particular link which I thought was quite nice is here. They have given some numerical examples on what happens when we run, let's say, search operations on large dictionaries or say. I hope this general discussion was somewhat interesting and useful to you. Both lists and dictionaries are absolutely very, very important in Python. Both have their own usage, but it's good to know what is the difference. As always, if you think this way of learning, where we build an activity, we discuss the different aspects of it, think of enhancing it, appeals to you, look at our website, because at YByte, we learn programming through such fun activities. Take care. Thank you so much. Bye-bye.